In the previous video, we have already integrated the tool in our code. Now in this video, we will learn how to enable continuous transmission. So for continuous transmission, there are two things. The first thing is that you will have to make sure that the board is able to transmit the signal again and again, and you're able to receive it repeatedly. And the second thing is that the process should be fast. Now, in order to ensure both these things, we will need to understand our tickle script. Now, when I open this tickle script, in this first part of the tickle script, the board will take some time to reset, and then there is this 30-second of wait time. After that, only you will be able to transmit and receive the data. But for continuous transmission, that part is not desirable. Hence, we will avoid programming the board again and again. And the second thing is that we will make use of the fact that the transmitter is already transmitting. So in the tickle script which we will now make for subsequent runs of the code, in that we will only turn on the receiver. We will read the samples from the address, and then we will switch off the receiver. Now here is a mistake that I have done in the previous part of the code. I did not specify the address of the BRAM which is allocated to DAC. So I will need to allocate that address as well. As I remember the address, I am already writing down the address. This is the address of the BRAM that is connected to ADC, where once the receiver is turned on, the data is being recorded. Now I will make a new tickle script. In that tickle script, I will go to the folder where the tickle script is situated. I will paste the path. After that, I will connect to this URL. After that, I will just specify the cable name which is being used. The cable name has been specified at a lot of places. I will take this cable name, which is loading the hardware. And I will paste this cable name here. After this, I am ready to go. I will just use the con command that will connect to the board. After I have connected to the board, now I need to go to the place where the folder where my file will be written onto. Once I have navigated to that folder, I know that my transmitter is still transmitting because I have not reprogrammed the board. The code that was initially there is already working. The transmitter is already transmitting the data. I just need to turn on the receiver, read the data, and then turn off the receiver. So I can just take out this much part of the code and paste it there. That's it. Now the receiver is ready for the continuous transmissions. The other thing that we can do is reading these many samples takes time. So we can reduce the number of samples to half of these samples. The half of these samples will be 62208 divided by 2. 31104 samples. That is equivalent to 15,552 complex samples. Here as well, I will change to these many samples. I will save this file as tutorial script for continuous runs. Now, the reason that I have chosen 31,000 samples is because for 31,000 samples, I have 15,000 complex samples. Now, if you remember, I needed to have at least 3 frames in one processing window. If I go below 15,000 samples, that means that will go around nearly equal to 12,000 samples. Then there is probability that in some window I might have 2 frames or even less than that. So in order to avoid that situation, I have kept at least 15,000 samples. So in every processing window, I have at least 3 frames to work with so that I have enough data to process. And also, the reason that I'm writing 62,000 frames is 62,000 real samples is because the size of the VRAM that we have is 128K. And if I'm writing it in int16 format, that means I have 2 bytes for one sample. So the number of samples that I can store in 128K is 64K. So when I'm around 62,000 samples, that is very nearly equal to 128K. Hence, the amount of noise that I have in VRAM is very less. So that is the reason I have come to around 62,000 samples. That is around 31,000 complex samples. So that was the explanation for for transmitting 62,000 samples in one go. And for receiving 31,000 samples, that is equivalent to 15,000 complex samples, is I need at least 3 frames for processing. So this is how the script for continuous transmission can be done. Now we will integrate this in the code, in the MATLAB code. So for the first time transmission, the code is already prepared. I will just take this part from where the new signal is being loaded. And I will continue it as many times as I want. If I want it 5 times, I will continue it 5 times. And the one more change that we are going to do is the tickle script that we have specified for the subsequent runs, we will specify the new tickle script that we have created. So I will copy the name of this tickle script and I will paste it here. And one more change that we have to do is since we have changed the number of samples that we are reading, now since in reading we are reading half the number of samples, so the data received size we don't need to specify, the data to be processed we don't need to specify. This is equal to length of data to be processed, that will be equal to 50,000 samples, and it will go into 15,000 complex samples. And again, this will be until 15,000 complex samples. So everything has been automatically taken care of. So these were the changes that had to be done for continuous runs. Now in the next part of the video, I will demonstrate continuous running of this code on RFSoC using antennas. Thank you.